Hello friends, a very warm welcome on our personal YouTube channel. Friends, in today's session, we will be talking about a topic which is underrated by the students who prepare for aptitude entrance examinations, management entrance examinations, or any examination which tests your aptitude. Now, the topic for the day is a square of a natural number. Now, why I'm saying that this topic is underrated because we feel that we know each and everything about a natural numbers square. We know how to calculate it, but we forget about some of the very important properties related to the perfect squares, related to the square of a natural number, which will be very useful. I would say useful while solving the question in less amount of time. So yes, if we know these properties, then any question which conventionally can be solved in a matter of 2 minutes can easily be solved in less than 30 seconds. All right. So friends, let's talk about natural numbers, the squares of natural numbers. But before starting this topic, a very small crisp introduction about myself. My name is Gaurav Gupta and I have a teaching experience of more than 16 years in national level institutes like Time, Career Launcher, IMS, and many more. Now, previously, I would say that in the last 17 years, I have written CAT each and every year. During these years, I have written GRE and GMAT just to test these examinations, just to test myself on these examinations, and I have scored these scores. All right, so this is about myself. Now, let's begin with square of a natural number. Now, talking about the area in which this particular topic will lie will be mathematical aptitude. Now, this can be a part of CAT entrance examination, other management entrance examination, civil services aptitude test. It can be used in CUET, IPMAT examinations, or any student who is in studying in class 7 up till class 12. So overall, I can say that this area is relevant for all the students who want to increase their aptitude level. All right. Now, the agenda that I'll be following in this session will be, I'll start with properties related to the unit digits of perfect squares. Then we'll talk about properties which are related to tens digit or the last two digits of a perfect square. Then talking about other useful properties like number of factors, which will be helpful as a shortcut in many questions. Then we'll talk about faster calculations of the squares of some numbers which are above 25. So this will be the agenda that I'll be following in today's session. So without any delay, let's begin with this session. Now, first of all, you should be knowing some prerequisites in order to understand how to quickly calculate square of a natural number and the properties related to that. So the prerequisite is very simple. You should be knowing the squares of the numbers up till 25. So first 25 natural numbers, these squares should be known. So I have displayed the squares of first 10 natural numbers. I am pretty sure that 100% of the students who are watching this session would know these numbers. But the next 10 numbers, probably some of you would not know these. Okay, so I'm just displaying these values so that you will have it in mind. You may note it down because these numbers will be frequently used in today's session. And then the application when you will be applying all these things while solving any question during practice or during the examination. So these are the squares of next 10 numbers, so up to 20, and another 5 numbers. So the squares of first 25 natural numbers, they should be known, they should be remembered by heart. रट लो इन चीजों को because they will be very helpful. Okay. Now, let's talk about the properties related to them. So I'll start with properties related to the unit digit of any, the square of any natural number. Okay. Now, if I'm talking about a natural number, so look at this part. If I'm talking about a natural number, any natural number will either end with 1 or 2, 3, 4, 5, 6, 7, 8, 9 or 0. Okay. So I'm talking about a natural number. It will end with any of these digits starting from 0 up till 9. Okay, right? So if I'll take numbers beyond 10, that is 11, 12, 13, 14, and look at the unit digit of these numbers, so these unit digits will be repeated, right? So any natural number will end with 0, 1, 2, 3, 4 up till 9. Okay. Now, if I'll take the square of these numbers, so any number which is ending with 1, when squared, the square will also end with 1. Alright. Then any number which is ending with 2, so 2 square is equal to 4. So the square of a number which is ending with 2 will end with 4. Okay, similarly, if a number is ending with 3, its square will end with 9. Any number which is ending with 4, the square will end with 6. I'm focusing on the unit digits only. Any number which is ending with 5, the square will end with 5. Ending with 6, the square will end with 6. Number ending with 7, the square will end with 7 square, that is 49. So the square will end with 9. Any number which is ending with 8, its square will end with 4. Any number which is ending with 9, the square will end with 1. And finally, any number which is ending with 0, the square will end with 0. Okay. So if you will look at the unit digits of the squares of first 10 natural numbers, then you will see that among the unit digits, you will have 0. Okay. So I can say that any perfect square can end with 0, right? So we have 0 as the unit digit of a perfect square. We have 1. So you can see that 1 is repeated twice. So yes, 1 can also be the unit digit of a perfect square. So I'll put 1. You will see that 2 and 3 are not present in this list of the unit digit of a perfect square. Okay. So it can be said that a perfect square can never end with 2 or 3, right? Now after 3, yes, we have 4, we have 5, we have 6, we don't have 7 and 8, and then we have 9. Okay, so overall it can be summarized that a square of a natural number can end with any of the unit digits starting from 0, 1, 4, 5, 6, or 9. All right. So the unit digit of a perfect square can be 0, 1, 4, 5, 6, or 9. If any number is ending with 2, 3, 7, or 8, then we can safely say that the number is not a perfect square. Okay. So I can say that this is a necessary but not sufficient condition to check whether a number is a perfect square or not. Okay. So just to identify if a number is a perfect square or not, you can use this particular method. Okay. So if any number is ending with 2, 3, 7, or 8, then definitely it is not a perfect square. If a number is ending with 0, 1, 4, 5, 6 or 9, then it may or may not be a perfect square. तो ऐसा जरूरी नहीं है कि अगर नंबर 0 से एंड कर रहा है या 1 से एंड कर रहा है या 4 से एंड कर रहा है तो वो नेसेसरली एक परफेक्ट स्क्वायर होगा. इट मे और मे नॉट बी अ परफेक्ट स्क्वायर, बट any number which is ending with 2, 3, 7 or 8 will definitely not be a perfect square. All right. Now, since the unit digits will keep on repeating, I can say that this property can be used as a general property related to the unit digit of a perfect square. All right. So here we have learned that a perfect square may end with 0, 1, 4, 5, 6 or 9. A perfect square will never end with 2, 3, 7 or 8. All right. So this is about the property related to the unit digit of a perfect square. Now let's move on and look at the property related to the last two digits of a perfect square. Okay. Now, as we have seen that the unit digit, it shows a certain kind of pattern. So does the last two digits. Now this will be slightly difficult to understand. Okay. But you all must focus on here. Now I have written the squares of first 25 natural numbers. Now just focus on the last two digits of these numbers. Okay. So Other than these three, the square of 5 which ends with 25, the square of 15 which also ends with 25, the square of 25 which also ends with 25, right? And then these two, square of 10 and square of 20, they are ending with double zero. Now, if you look at the last two digits of the squares of the remaining numbers, okay, I have marked 5 numbers. Okay, don't look at these 5 numbers, just look at the others. Then the last two digits are unique. Okay, so the last two digits of 1 are 01, last two digits of the square of 2 are 04, then the square of 3 ends with 09, square of 4 ends with 1616, and these are unique when I talk about first 25 natural number squares. Okay, so among these 25 numbers, you will see that there is only one number whose square ends with 16. Again, there is only one number whose square ends with 49. All right. So very small, tiny observation. And now using this observation, I can generalize one particular thing. So let's talk about that. Okay. Now, these last two digits of the perfect squares will keep repeating in a particular order. Yes. So if I talk about the last two digits of the squares above 25, then you will not find any new pair of last two digits. कोई भी new pair of last two digits नहीं होगा. It will be present among the last two digits of first 25 natural numbers. Yes. So I'll repeat. The last two digits of the squares of natural numbers will repeat after 25. 25 के बाद repetition start हो जाएगा. Okay. And how this repetition will happen? Now, the last two digits of 26 square, the last two digits of 26 square will be same as the last two digits of 24 square. Okay, so 24 का square क्या था? 576. The square of 26 will be or is 676. Okay, so I can say that 76 are the last two digits. Similarly, last two digits of 27 square will be same as the last two digits of 23 square. So it will be 29. So 27 square is 729, the last two digits being 29. Similarly, last two digits of 28 square will be same as the last two digits of 22 square, which will be 84. And they will keep on repeating in this order, or I can say that in this reverse order up till 50 square. Okay, right? So I can say that 49 square, the last two digits will be the last two digits of 1 square, that is 01. Okay, similarly, last two digits of 50 square, no need to talk about that, will be 00. Now, after 50, what will happen? 51 onwards, so 51 square, 52 square, and so on up till 75 square. Okay, so starting from 51 square up till 75 square, the last two digits will repeat in the normal sequence. So you can say that 51 square, the last two digits will be same as the square of 1. Okay, so 51 square, the last two digits will be 01. 52 square, it will be 04. So look at the beginning, look at the starting. So these last two digits will repeat in the same order as it was repeating for the last two digits of numbers starting from 1. Okay, so 53 square, the last two digits will be 09, and so on. 75 square, the last two digits will be 25. Now after 75, they will repeat in the reverse order, and it keeps on happening up till infinity. Okay, so here we have known that the last two digits of the squares of numbers starting from 1 up till 25, these should be known, and they will keep on repeating in a certain order after 25 up till infinity. All right, okay. Now, knowing this particular property of last two digits will help you in determining or in shortlisting the tens digit of perfect squares. Okay, so now let's talk about tens digit, properties related to the tens digit of a perfect square. Now the property that we have just now discussed, this particular property will be very useful at higher level of examinations, like in CAT or in other management entrance examinations. This particular property will be very handy. Similarly, in examinations like CUET, IPMAT, all right, or in any aptitude examination, this particular property will be very useful when it comes to finding the last two digits of a number raised to the power any other number. Not just squares, but any random number. All right. Okay. Now moving ahead, we talk about how to find out or how to know what can or what cannot be the tens digit of a perfect square. Okay. So our next property is knowing the tens digit of a perfect square. Now for this, I would write what can be the possibilities of the unit digit of a perfect square. एक perfect square का unit digit क्या क्या हो सकता है? We have just discussed, like we have discussed it a few minutes back. Okay, so the unit digit of a perfect square or a perfect square can end with either 0 or 1. It cannot end with 2 or 3. It can end with 4, 5, 6 or 9. It cannot end with 7 or 8. All right. So these can be the possible unit digits of a perfect square. Now we are talking about last but one digit. That means the tens digit. Okay. Now, starting from the first, when a perfect square is ending with 0. Now look at two numbers here whose squares are ending with zeros. Okay. So any number which will have 0 at its end when squared will also end with 0. So square of a number which is ending with 0 will also end with 0. But the number of zeros becomes twice. So 10 square, the last two digits will be 00. 20 square, the last two digits will be 00, and so on. Okay. So if a perfect square is ending with 0, then its tens digit will also be 0. All right. Also, you can say that if a perfect square is ending with 0, then it will always end with even number of zeros. Okay. So there will be either 2 zeros at the end, there will be either 4 zeros at the end, or 6 zeros, or 8 zeros, or 10 zeros, and so on. A perfect square can never end with odd number of zeros. कभी भी odd number of zeros नहीं होंगे किसी भी perfect square के end में. All right. So I can say that a perfect square will always end with even number of zeros. Okay. Right. A perfect square will always end with even number of zeros. Right. Now let's move on and look at the second part. Now when the unit digit is 1. Okay. So now look at the numbers whose square is ending with 1. So we have this one. So 1 square, the last two digits are 0, 1. 11 square, the last two digits are 2, 1. 21 square, the last two digits are 4, 1. Then 19 square, the last two digits are 6, 1. And then 9 square, the last two digits are 8, 1. So when the unit digit is 1, the tens digit is either 0, 2, 4, 6 or 8. 0, 2, 4, 6, 8. What are these numbers? These are even numbers. Okay. So if a perfect square is ending with 1, the tens digit will always be an even number. That means it will either be 0, it will be 2, 4, 6 or 8. Right? Okay. So now we can say that if a number is ending with, let's say 31, किसी भी एक number के last two digits 31 है, 31, then I can say that this number cannot be a perfect square. Okay, so these rules can be easily used, can be used for eliminations. Okay, so एक number को perfect square नहीं है, ये चीज find out करने के लिए हम easily use कर सकते हैं. Right? So This particular thing told us that if the unit digit of a perfect square is 1, then the tens digit will always be an even number. It will never be an odd number. Okay, and let's move on and look at the next thing. When a perfect square is ending with 4. So again, I will look at these 25 numbers wherever a perfect square is ending with 4. So I'll quickly mark those numbers. So again, you will find these 5 numbers in which the squares are ending with 4. Now just observe their tens digit. So the tens digit is 0. Yes, it is. Then it is 2. It is 4. It is 6. And it is also 8. So ending with 4, the tens digit is 0, 2, 4, 6 or 8. Once again, it is an even number. Alright. So just like the previous case, again here, the tens digit will always be an even number, 0, 2, 4, 6 or 8. Or in other words, I can say that it will never be an odd number. Alright. Okay. Now moving ahead, any perfect square ending with 5. Now this can be easily answered. Now you all would know that if a perfect square is ending with 5, the last but one digit, the tens digit will always be 2. No, not an even number, not any even number. It will always be 2. Hamesha 2 hoga. Other than 2, no other digit is possible here. Okay. So if a perfect square is ending with 5, the tens digit will always be 2. Remember this particular thing. Okay. Now moving on, the next case, if a perfect square is ending with 6. So once again, I'll mark the numbers 16, 96, 76, 36 and 56. So among the unit digits, the unit digit is 6, and then among the tens digit, if the unit digit is 6, then among the tens digit we have 1, 3, 5, 7 and 9. Okay, so we have 1, 3, 5, 7 and 9. So it can be generalized and can be said that the tens digit will always be an odd number, 1, 3, 5, 7 or 9. Okay. Now final case, when the unit digit is 9, when the unit digit of a perfect square is 9, so again the tens digit can be 0, 6, 2, 4 or 8. So every even number is considered here once again. So the tens digit will be an even number among 0, 2, 4, 6 or 8. Alright, fine. So these are some general properties which are related to finding the unit digit, the last 2 digits or the tens digit of a perfect square. Now these are general properties. Yes, there is no exception for them. Okay, so you can use them at every time. Alright, fine. Now friends, moving on, talking about some other properties of perfect squares. Now one very useful property that you might not feel that it is relevant right now, but this is a hidden property of perfect squares. A very less number of students would know that, but a very useful property and helpful in lots of logical questions in your aptitude examinations. Now, first of all, let's understand what can be the number of factors of a perfect square. Okay, I'll take an example. So let's take a square, a perfect square 16, and I will write all the factors of this number. Okay, now what are factors of the number? Factor of any number are all those numbers which can completely divide the given number. Okay, so 16 is completely divisible by 1, 2, 4, 8 and 16. Okay, I'll pick up one more number. Let's say 36. 36 is also a perfect square. I'll write all the factors of 36. So 1, 2, 3, 4, 6, 9, 12, 18 and 36. So these are all the factors of 36, right? Now, one very small thing, one very general thing that is followed by every number, not just perfect squares, but every number. So if you are writing all the factors of any number in increasing order, starting from number 1 up to the number itself, then one peculiar thing can always be noticed is, look at the first factor and the last factor. So the product of first and last factor will always be the number itself. It will happen with every number, not just perfect squares, but with every number. Okay. So the product of first and last factor will be the number itself. Similarly, second and second last factor, the product of these two will again be the number itself. Third and third last factor, fourth and fourth last factor, and it will happen with every number. Again and again I'm repeating this. Okay, so this will happen with every number. Now, only in perfect squares, if you will look at the middlemost factor, this will be left alone. Okay, ये किसी के साथ कोई पेयर नहीं बना रहा है. Like 4 multiply 9 is 36, 3 multiply 12 is 36, 2 multiply 18 will be 36, 1 into 36 is equal to 36. Okay, so we have a pairing, we have a pair for every two factors which are equidistant from both the ends. But 6, for this particular case, 6 is left alone. Why this number is left alone? 6 is the square root of 36. Okay, so I can say that 6 multiplied by 6 is equal to 36. But if I'm writing all the factors of 36, I will not repeat 6. मैं 6 को repeat नहीं करूंगा. 6 will be written only once. Okay, and hence this property arises which says that the number of factors of every perfect square will be an odd number. So a perfect square will have odd number of factors. A perfect square will never have even number of factors, right? So this is one very important, very useful property of a perfect square, and you can test this property. You can just derive this property by yourself by considering any perfect square, write all its factors, and then start making the pairs. You will realize that the square root of that number, right? The square root of that number will be the middlemost factor, and it will not form any pair with any other factor of that perfect square. All right. So we can say that the number of factors of any perfect square will always be an odd number, right? Okay. Now let's look at one very common question that is asked in the examinations using this property. Okay, so let's read this question. Now, in the first go, you will think that this question is very difficult. Okay, and the first impression will be, yaar, is question ko chodo, next question pe chalte hain. But if you know this property, which is related to the number of factors of a perfect square, then this question can be solved in a matter of 10 to 15 seconds, other than the time that you will take to read this question. Okay. So let's read it out. There are 1000 boxes all closed, numbered 1 to 1000 in a room with 1000 students standing outside the room. So we have 1000 boxes inside a room. All the boxes are initially closed, and these boxes are numbered starting from 1 up till 1000, right? Now first student enters the room and opens all the boxes. So originally the boxes were closed. Now first student enters and he will open all the boxes. The second student now enters and closed every box which is numbered as a multiple of 2. So जो भी box का number 2 का multiple था, the second student closed every box. Okay. Now the third student enters and changed the state of every box which is numbered as a multiple of 3. So now this third student will go to all the boxes which are numbered as multiples of 3. If that box is open, he will close it. If the box is closed, he will open it. Okay. Now it will keep on happening up till 1000th student. So that means the fourth student will come and he will go to every fourth box, every box which is numbered as a multiple of 4, and will change the state of those boxes. Okay. Now this process will keep on continuing up till 1000 student, right? Now at the end, after this 1000 student, we have to find out how many boxes are open or how many boxes are closed at the end. Okay. Now let's understand the dynamics behind this question. Okay. Now if I look at any random box, okay, किसी भी एक box को उठा लेते हैं. Let's pick up the box which is numbered 10. Okay. Now which all students will come to this box? The first student will go to every box. The second student will go to every box which is a multiple of 2. So 10 is a multiple of 2. So second student will go to this box. Okay. Now third student will go to every box which is a multiple of 3. So 3 into 2 is 6, then 9, then 12, then 15. So 10 is not a multiple of 3. So the third student will not go to box number 10. Fourth student will again not go to box number 10 because 10 is not a multiple of 4, or the other way around, 4 is not the factor of 10. Okay. Then student number 5 will go to box number 10 because student 5 will go to 5, 10, 15, all the multiples of 5. So 10 is a multiple of 5 or 5 is a factor of 10. So box number 10 will be approached by student number 5. So I can say that any box will be touched by or will be processed by any student who is the factor of that box number. So box number 10 will be touched by student number 1, student number 2, student number 5 and student number 10. Now what are these numbers? 1, 2, 5 and 10. These are the factors of 10. ये 10 के factors हैं. Okay, so box number 10 is approached by first student, second, fifth and 10th student. Likewise, let's talk about any other random box. Let's say box number 18. So box number 18 will be touched by any student who is the factor of 18. So first student, second student, third student, not the fourth student because 4 is not the factor of 18, not fifth, then sixth student, yes, it will be. Then 7, 8, nahi hoga, 9, and then directly 18. Okay, right? Now I'll write one more number. Let's say 36. So हमने previously example लिया था 36 का. So box number 36 will be touched by 1, 2, 3, 4, 6, 9, 12, 18, and 36. These students. Okay. Now, originally all these boxes were closed. So any box which is touched by 2 students or 4 students or 6 students or even number of students will be finally closed. Okay. Initially the box was closed. If a box is touched by 2 students, first will open it, second will close it. Then third will open it, fourth will close it. So if even number of students are approaching any box, then finally the box will be closed. Okay. So box number 10 is approached by 4 students, which is an even number. So this box will be closed at the end, right? Similarly, box number 18, number of factors is 1, 2, 3, 4, 5, 6. 6 factors. It will be approached by 6 students. It is approached by even number of students. So I can say that this box will also be finally closed. But for the number 36, which we already know that the number of factors is an odd number. Now, if a box is approached by only 1 student or 3 students, right, or 5 students, then I can say that this box will be finally opened. Okay, right? So it can now be generalized that any box whose number is a perfect square, किसी भी box का number अगर perfect square है, then it will be touched by an odd number of people because it has odd number of factors and it will be finally opened. All right. So overall, the gist of this question is just to find out how many perfect squares are there up till 1000. 1000 तक कितने perfect squares हैं? ठीक है, अब ये चीज बहुत इजी है, अप्रोक्सीमेट स्क्वायर रूट ऑफ 1000 कैलकुलेट कर लो, और विद ड्यू प्रैक्टिस इफ यू रिमेंबर दैट, और थोड़ा सा हिट एंड ट्रायल कर लो, 30 square is 900. So I can say that up till 900 there are 30 perfect squares, right? ठीक है ना, 900 तक कितने perfect squares होंगे? 30, because 30 square is 900. 31 square, if you know, 961. 32 square is 1024. So you will have to stop here. Up till 961, there are 31 numbers which are perfect squares. Okay, next perfect square is 1024, which is above 1000. Okay, so that means up till 1000, there are 31 perfect squares, and hence the answer of this question will be 31. So out of 1000 boxes, finally only 31 boxes will remain open, and the remaining 1000 minus 31, 969 boxes will be closed. Okay, so yes, the explanation was long, but the logic was very small. So if you know this logic, I can say that yes, now you also will believe that this question can be solved in less than 30 seconds. ठीक है, अगर perfect squares properly याद हैं, so 10 seconds में भी काम बन सकता है, but maximum 30 seconds you should not be taking more than that. Okay, so this was one thing that was related to the properties of the number of factors of a perfect square. All right, now let's move on towards the last part of this session, where we'll discuss like, since we already remember the squares of first 25 natural numbers, how we can use these squares of first 25 natural numbers to find out the squares of other numbers. Okay, so we'll spend 5 more minutes on this, right? So let's quickly understand this. So I'm assuming that we already remember the squares of first 25 natural numbers. Okay, can I assume this, or do you want me to copy these things? Okay, chalo copy kar lete hain. So I'll quickly copy these numbers on the screen. Okay, so now you can see that these are the squares of first 25 natural numbers, right? Now I will use these 25 numbers, I'll use these squares of first 25 natural numbers to calculate the squares of numbers which are above 25. ठीक है? Okay, now first of all I'll define the range up till 75. So 75 तक का कोई भी number होगा, any number up till 75, you can calculate the square of that number in a matter of seconds. ठीक है? You don't require any kind of multiplication, you don't require any kind of division, you just require simple subtractions. ठीक है? So minus करना आना चाहिए, easily answer आ जाएगा. ठीक? Another thing is, first 25 natural numbers, these squares should be remembered. Okay, they should be in your mind. Okay, now let's see how this can be done. Now I'll take an example first of all to explain you, and then I will generalize the result. So let's say you have to calculate the square of 43. Okay, now the process is divided in two parts. The answer will be divided in two parts, the right hand side part and the left hand side part. So first of all, let's talk about the right hand side part. So 43 square, to calculate this, first of all I'll take the difference of 43 from 50. Difference of 43 from 50, 50 से difference लेना है. So difference of 43 from 50 is 7. What is the square of 7? The square of 7 is 49. Write this number as it is. Okay, so in the first step I've taken the difference of the number from 50, I've taken the square of that difference, and I have written that square. Okay, or the method says that you will write the last two digits of this square. Now since 49 is already a 2-digit number, I will write 49 as it is. This was the first step. The second step, take the difference of 43 from 25. 25 से difference लेना है. So in both the cases we are taking the difference of this number First with 50 and then with 25. So difference of 43 with 25 from 25 is 18. Write it as it is. Don't square it, write it as it is. So the first part was difference from 50, the square of that, and the second part difference from 25, and you will write it as it is. And this is the square of 43, 1849, just like that. Okay, let's repeat this. I'll take another example, 46 square. So first step, difference of 46 from 50 is 4. The square of 4 is 16. The second step, difference of 46 from 25. The difference is 21. Write it as it is. 2116 is your answer. 2116 is the square of 46. Okay, interesting. Now let's look at this method properly, okay, for other numbers, because we are generalizing this method, right? Now let's calculate the square of 38. Now difference of 38 from 50 is 12. 12 square is 144. Now 144 is a 3-digit number. I will retain the last 2 digits and will send 1 as the carry forward for the next step. I'll repeat, 38 square to be calculated. So I'll take first of all the difference of 38 from 50 as usual. So difference of 38 from 50 is 12. The square of 12 is 144. I'll write 44, the last 2 digits, and send 1 as the carry forward for the next step. Then in the next step, I'll take the difference of 38 from 25. The difference is 13 plus 1, the carry forward, 14. So 14 will be written, and 1444 is the square of 38. Right? Again, let's take one more example. 67 square. You can use this method exactly this method to find out the squares up till 75. 75 तक तो easily आज हो गया है, ठीक है? So 67 square. Now difference of 67 from 50. First step. Difference of 67 from 50 is 17. Square of 17 is 289. So I'll write 89, the last 2 digits, and will send 2 as the carry forward. Second step, difference of 67 from 25. सिर्फ difference देखना है, okay? So please don't make it complex. Don't make any kind of error in this calculation. So difference of 67 from 25 is 42. 42 plus 2 is 44. So 4489 is the square of 67. Simple. एक और नंबर लेते हैं, 73 square. So square of 73. Again, the first step will be same. Difference of 73 from 50. Difference of 73 from 50 is 23. 23 square. अभी ये रेफर कर सकते हो टेबल. So 23 square is 529. Write 29 and send 5 as the carry forward. Then after that, difference of 73 from 25. ये थोड़ा tough है, but practice करोगे, at least subtractions तो control में होनी चाहिए. So 73's difference from 25 is 48. 48 plus 5 is 53. So 5329 is the square of 73. Right? One small disclaimer, एक छोटा सा चीजें जो ध्यान रखना है while calculating squares of the numbers like 48. Be careful, huh? 48 square. Now difference of 48 from 50 is 2. The square of 2 is, no, it's not 4, it's 04. Okay? So the square of 2 is 04. Make it a 2-digit number. Okay? And then difference of 48 from 25 is 23. So 2304 is the square of 48. Now the method that I've just told you, this can be extended up to any number to find out the square of any number up till 75. Alright? Now what for the numbers above 75? So rule is similar. ठीक है, similar है, exactly same नहीं है, because we are increasing our range. So rule is similar. So let's see what to do for this rule. ठीक है? So by now you would have remembered the squares of first 25 numbers. Okay, so let's look at What will happen for the numbers above 75 or numbers starting from 75 up till 125? Okay? So let's say we have to calculate the square of 93. As a first step, earlier we were taking the difference from 50. To make things easier for us, take the difference from 100. Okay? So difference of 93 from 100. So difference is 7. The square of 7 is 49. So in the first step, I have taken the difference from 100 and I have taken square of that. 7 square is 49. I have written 49. Let's look at the next step. Now in the next step, carefully, now take the difference from 50 and whatever this difference is, just double that difference, multiply it by 2. So difference of 93 from 50 is 43. Double of 43 is 86. So 8649 is the square of 93. I'll repeat this exactly the same thing for another number. So let's say we have to find out the square of 116. Okay. So first of all, the difference of 116 from 100 is 16. The square of 16 is 256. I'll retain the last two digits, 56, and will send 2 as the carry forward. Now carefully the next step. Difference of 116 from 50. 50 से difference कितना है? वो calculate करना है. So it is 66, right? 66 is the difference from 50, right? Multiplied by 2. So 66 into 2 is 132 and then carry forward add कर दो 2, right? So I'll repeat, 116 का difference 50 से लेना है, that is 66. 66 multiplied by 2 is 132. 132 plus the carry forward 134. Okay, so 13456 is the square of 116. Now finally, let's take one more example. The square of let's say 89, right? So 89 का difference 100 से कितना होता है? 11. 11 square is 121. Carry forward 1. Then difference of 89 from 50 is 39. 39 का double 78 plus 1 79. Now make sure that you repeat these things, you repeat all these methods at least for some more natural numbers. Practice this at home, then only you'll be able to apply all these things in the examination. Don't think that just by watching this session, just by practicing one or two questions, you will be able to apply these methods that you have known here in the examination without committing an error. No, it is not possible. So, in order to apply anything, I would say that without committing an error, you will first of all have to practice. Okay, so practice as many questions as you can, or practice minimum number of questions that will enable you to remember this technique for a longer period of time. Keep revising it, keep practicing it, keep implementing all these calculation techniques while you are solving the questions, and then you will be fine. All right. So friends, that is all from my side in this session. Please do like this session. If you have any kind of question, if you have any comments on this session, please do post your comments in the comment section. Share this session with your friends so that they will also be able to gain some knowledge. And please do subscribe this channel. So that's all from my side for the day. All the very best to all of you. We'll see you in yet another session. All the very best. Bye-bye.